This next chart we're going to look at is about near-Earth asteroids discovered and the rate at which the number discovered has increased. Now, through virtually the entirety of the 20th century, there was no capacity via which to detect near-Earth asteroids because they were too small for the telescopes of the time. Now, in this upper right-hand corner, you can see a tag to another video I made about how telescope power is rising exponentially because it rises as the square root of computing power, and that has led to finally being able to detect these near-Earth asteroids at an exponentially rising rate to the extent that now we don't even have to worry about asteroid impacts on the Earth anymore. But as recently as the 1990s, we could have been hit by a surprise asteroid and could not have detected it in advance or done anything about it, and there were even a lot of films in the late 1990s about this scenario. But as we got into the 21st century, computational power rose, and we were able to detect these asteroids. Time is moving forward as we go rightwards, and this vertical axis is cumulative number of discovered near-Earth asteroids. Now, why is discovering near-Earth asteroids important? The primary reason is that if there's an asteroid that is going to hit the Earth, that can be very disruptive. It doesn't have to be nearly as big as the one that led to the extinction of the dinosaurs. That was an asteroid 10 kilometers in diameter. Something that size only hits once every several tens of millions of years. But even a 1 kilometer diameter asteroid would be extremely destructive to the Earth, and even a 140 meter asteroid hitting the Earth would be disruptive to our fragile human economy, all our interconnected economic mediums such as the stock market, tsunamis that destroy coastal cities, and so forth. So it's definitely worth our while to detect all of these near-Earth asteroids at least up to 140 meters in size. This chart happens to be from the NASA Jet Propulsion Laboratory, and the link will be in the description box below. And of course, this is something that the US government pays for, meaning the US taxpayer pays for, but the whole world benefits from because asteroid impact is also a borderless thing. But as computational power progressed, we now have a situation where we have detected virtually all of the asteroids that are 1 kilometer in diameter or larger. That is the red zone, which is flattening. And even the orange category is flattening. While it is rising, it is not rising exponentially like the blue is. These are the really small asteroids that we have to find, but the blue is not even that important because asteroids smaller than 140 meters will usually burn up in the atmosphere. The few that don't are in the blue zone very near to the orange zone, so if you want to be super cautious, you can go from here up to maybe here. If not 140 meters, 130, 120, fine, go all the way down to 80 meters even, but that's very, very cautious. So because this rate of rise is flattening, remember this is a straight line, which means the percentage year-over-year growth rate is going down. Only with the grand total is the percentage year-over-year growth rate still relatively constant. That's why we have an exponentially rising curve. But because we are rapidly finding all of the asteroids that could pose a danger to us, and we can calculate when they might impact, we have a lot more data to work with now. In this video up here in the upper right-hand corner, I explain why we no longer have to worry about asteroid impacts on the Earth. That problem, while never completely zero, is almost going to be gone. Sure, a comet could hit the Earth, but that is extremely infrequent, and I wouldn't worry about that either. A near-Earth asteroid was something to worry about, but when we know where they all are, we can do something about it. Now, the second useful reason to map near-Earth asteroids is because many of them contain precious metals such as gold, platinum, and silver, and being able to harness these asteroids can greatly increase the supply of these precious metals. A 1 kilometer asteroid easily has 200 billion tons of metals in it. A good portion of those might be gold or silver because the asteroid's low gravity means that these heavier metals are more evenly distributed throughout the asteroid versus in the Earth. Heavier metals like gold mostly sunk to the center of the Earth and are inaccessible, and very little is still in the surface. This will of course contribute to more technological deflation because the cost of all of these metals will go down once we even have a 10% chance of accessing them. That is another subject I speak about on this channel. Thanks for watching.